My name is Chris Gordon. I'm a lecturer here, and I've been here about a year and a half, and my main area of interest is cosmology. My job is basically three different parts. The one part, of course, is lecturing courses. Also, I get time to do some research, so I, at the moment, mainly concentrating on trying to understand what this type of matter known as dark matter is, which makes up, it's about 4 times more common than ordinary matter that we know of, but we only have been able to detect it gravitationally so far. After my undergraduate degree, I did 4 years, and then I started a master's, and then I kind of decided I'd go work in industry. Halfway through the master's, I'm originally from South Africa, so the master's there is 2 years, and so halfway through I started working in industry. I originally worked for an agricultural and environmental monitoring agency, working with satellite data to try and tell how much crops were growing and that kind of thing. And then after spending a couple of years there, I went and worked for companies like Anglo-American and De Beers, trying to use satellite data and aerial reconnaissance data for finding mineral deposits. I went and did a PhD at the University of Portsmouth in cosmology. Well, it's I've always loved physics. I think it's amazing how we're able to understand and learn so much about the world, and so I really enjoy the opportunity to be working in physics and understanding physics better, and also contributing to this huge body of knowledge that's been developed by doing research and finding out more about our universe. Yes, it's a mixture of things. Some physicists are very theoretical in that they will just be working with abstract concepts and equations. And then others may be very much orientated towards building telescopes or instruments for detecting things. I'm kind of somewhere in between. A lot of my work, I find, is just trying to understand what people have already done. So reading through articles and then thinking about possible explanations for observations. This beach ball was produced by an experiment known as WMAP, the Wilkinson Microwave Anisotropy Probe. And so what they did is they did a kind of map of the cosmic microwave background. So it appears that we're living in this kind of huge sea of microwaves, which all have a very low temperature of about 3 degrees Kelvin. And these fit very well with the theory that they're actually remnants of the hot Big Bang from the early universe. So this big bright line that you see around the center is our Milky Way galaxy, because we're sitting kind of in this galaxy, and it has its own microwave emissions, and so unfortunately that part of the sky we can't really see what the primordial microwave emissions looked like. So often what's done is they just cut out that central part because that's not part of the snapshot of the early universe.